Today we are going to be going over adding rational expressions. So this is a bit more complicated than multiplying and dividing, mainly because we have to get a common denominator first. For this problem, I noticed the lowest common denominator. I'm just going to get the best one if I just multiply both fractions by the opposite denominator. So I'm going to take the n plus 3 over 3n plus 1, and I am going to multiply the top and the bottom by n minus 1. Right? It's like multiplying it by 1, so it's not going to change too much. And then the second fraction, 4 over n minus 1, I'm going to multiply that by the denominator of the other fraction. So 3n plus 1 over 3n plus 1. And then let's just not forget that this is an adding problem. So what I'm going to do, I'm going to go through and I'm going to multiply, but I'm actually not going to multiply on the bottom, but I am going to multiply on the top. So for the bottom, I'm just going to leave it as a 3n plus 1 times n minus 1. But on the top, I am actually going to do any distributing or multiplying out the binomials. So for this first one we have up here, n times n is going to be n squared. Then I'm going to have n times negative 1, which is minus 1n. Sorry, I wanted that in blue. Minus 1n. And then I have to do 3 times n, so I'm going to have a positive 3n. And then the last bit, 3 times negative 1, is going to be a negative 3. I'm going to have to expand this just a little bit because I'm running out of space. And now what I'm going to do is we have a plus sign because we're adding these two fractions. That's what the whole problem is. And then I'm going to put the whole second half in parentheses. The reason why I do this is because it's just kind of a good habit to get into, that the whole first half is getting added to the second half. It's also really important for tomorrow when we get into subtraction because you're going to need to distribute that subtraction sign. So I just like getting in the habit of it now, of putting the whole second half in parentheses. So I'm going to do 4 times 3n, which would give me 12n. And then I'm going to do 4 times 1, which is just a positive 4. What we're going to do here is combine any like terms and do any simplifying that we can. Okay, so I have on the bottom, we haven't really done anything, so it's going to say a 3n plus 1 and then an n minus 1. On the top, my n squared has no like term, so it's going to stay an n squared. If I just look at my n values, I have minus n plus 3n. There is a plus 12n. So combining all of those together, I end up with a 14n, positive 14n. And then for the last bit, I have a minus 3 and a plus 4, so that would give me a plus 1. So what you want to do now is see if you can factor the numerator, because remember, if it factors nicely, maybe we can cancel out with the bottom and we'll have found a hole in the graph. So if I try to factor out n squared plus 14n plus 1, something that multiplies to 1 and adds to 14, it's not going to be anything nice. It's certainly not going to be 3n plus 1 or n minus 1. So I'm going to say that that is as simplified as it can be, but now we still need to look for excluded values. Remember, if there are none, you would say none. But we actually have some issues because if you notice, the denominator can equal 0. So we need to know, well, when does 3n plus 1 equal 0? And when does n minus 1 equal 0? Okay. N minus 1 equals 0 is pretty easy, I think, at n equals 1. The other one, I don't know, I think is easy, but there's a little bit more steps. Subtract 1 from both sides and then divide by 3, and you get a negative 1/3. So remember, that's where the denominator equals 0. So that means that they're asymptotes at n equals negative 1/3 and 1. That would be the final answer for this one.